Hello everyone, in this video I'm going to be explaining an electrolysis question taken from June 2022. So let us get started. Yes, so this question, it says figure 5 shows a line diagram representing the electrolytic cell using the electrolysis of aqueous copper 2 sulfate solution using copper electrodes. So let us highlight some keywords here, right? So it says we're using aqueous copper 2 sulfate. Once you see the word aqueous, it means that water is present, right? And we're also using copper electrodes, and of course we know that copper electrodes are active. They take part in the electrolytic process. They get decomposed, they get ionized. That's what's going to happen to copper. So I'm just going to indicate here it gets ionized, right? Okay, so looking at our cell, that's our cell there. We have A for one of the electrodes, B for another. We have our battery. Yes, let us answer the question. So it says state whether the electrodes used are active or inert. So, and we need to give a reason. That's 2 marks. It is active. The electrodes is active. This is because the copper electrode will take part in the electrolytic process and is ionized. Simple, right? Some other examples of active electrodes are, for example, iron. So Fe is another example of active electrode. So you have iron, zinc, aluminum. Notice how they're metals, right? So your metals are really active electrodes. They get decomposed, they get ionized, right? I should not say the word decompose. I'm going to say the correct term, ionized. They get ionized into their ions. So Fe will become Fe2 plus, right? Zinc will become Zn2 plus, and aluminum will become Al3 plus. That's what happens to an active electrode. In the case of copper, of course, it's going to go from Cu to Cu2 plus. It gets ionized, right? I know that all of these electrodes are solids. So it goes from the solid state to the ionized state, which is also aqueous, right? Now I'm just going to do a little diversion, because yes, we understand what active electrodes are, but we need to know what our inert electrodes are, right? Sometimes you see those questions. The inert electrodes are the ones that don't take part in the chemical reaction, or let me not say chemical reaction, let me say in the electrolytic process, and also in the reaction, of course, right? They don't take part in the electrolytic process at all, right? So, for example, graphite is made up of carbon and mercury. Plastic is not an example. Plastic does not conduct electricity, right? Silicon is also not an example. For these, know that they all conduct electricity. However, the active ones take part in the electrolytic process, but the inert electrodes do not take part in the electrolytic process. So for graphite, of course, it will not become an ion, right? Mercury, it will not become an ion. Okay, let me get back. So that would have been 2 marks for just giving the reason. Next question, describe what occurs at the cathode and anode in an electrolytic cell. And I believe this is talking about the type of reaction. Now, how I remember this is I use my vowels. If you cannot use the vowels, then that's fine. So since anode begins with A and O is also a vowel, oxidation occurs at the anode. And if oxidation occurs at the anode, then reduction occurs at the cathode. Right, so it says describe what occurs at the cathode and what occurs at the anode. So let us answer. Okay, so we can say that simply at, I'm gonna put reduction occurs at the cathode, reduction occurs at the cathode, and we know that reduction is the gain of electrons. We're gaining electrons. And whenever you do answer your questions, please put them into complete sentences. Yes, so reduction occurs at the cathode while oxidation occurs at the anode. And oxidation is the loss of electrons. Nice. Now we're at our next question. So it says, state which electrode in figure 5 on page 16 is the cathode and which is the anode, right? And we have to look at the charges. So note that right here we have a positive terminal on the battery. So our left has a positive terminal on the battery, which means that the electrode that is connected to it will be positive, right? That's how we complete the circuit. A positive electrode will be connected to a positive battery, and a negative electrode will be connected to a negative battery, right? And the positive electrode is an anode. The anode is positive, it accepts anions, right, which are negative. I hope you see what's happening right there. While the cathode is negative, and the cathode accepts cations. And of course the cations will be positive. So you have positive going to negative, right? We have positive going to negative, and then we have negative going to positive. And of course you can see that the words relate. Anions to anode, cations to cathode. Anode is positive, cathode is negative. Alright, so let us go back. Electrode A is anode and B is cathode. Nice. Identify the ions that will migrate to the cathode and the anode. Yes, so remember that earlier when we looked at the question, it said that we have aqueous copper sulfate, right? Aqueous copper sulfate. Water is present and copper sulfate is also present. So we need to write out all the ions that will be present in water and copper sulfate. And since it says ions, we're going to write the ions. We need to see charges, right? So let me just do a little section over here. So I'm going to have Cu2 plus and SO4 2 minus coming from the copper sulfate, and from water we have hydrogen plus and hydroxide minus, right? And remember earlier we said that the anode accepts anions, and the anions are negatively charged, right? Or anions are negatively charged. So this goes to the anode and these will go to our cathode. So I'm going to write in all my electrons. So Cu2 plus, H plus, and OH minus, SO4 2 minus. Notice how I have my charges because those are ions, right? You could also write the word form of it. You could say copper ion, hydrogen ion, sulfate ion, hydroxide ion. But I do recommend you writing out your actual chemical symbol and their charges. So the next one says, write the half equation to show the substance produced at the cathode and the anode. And this question actually goes back to preferential discharge. Right, let me just scroll up to my question to see if there were any factors. No. Okay. Yes, there is actually one. Yes. So it says write the equation to show the substance is produced at the cathode and the anode. So at the cathode, we have two ions that are being discharged. Yes, at the cathode we have the copper and we have the hydrogen. Right. Now, there's only one factor that affects preferential discharge at the cathode. So let us do that right there. I'm going to do preferential discharge. And for the cathode, as I say, it's one factor, and that is the position in the electrochemical series. Right? Now, what that means is that the lower you are in the electrochemical series, the more likely you are to be discharged. That's what happens. So the lowest ion will be discharged. And you can, of course, try to pull up an electrochemical series on your device. I always try to remember the last 3 ones because those are the ones that often show up. Right? So the last 3 on the series, we have hydrogen, then we have copper, and then we have silver. Right? And note that these are not so reactive, so that's why they get discharged. So in this case, since the 2 ions that we're considering, we have copper and hydrogen, right? Now, the one that is lower is, of course, copper. So this is the equation that we're going to write for at the cathode, right? Because copper is lower in the series than hydrogen. So let us write. So it's going to be Cu2 plus to give, and this is aqueous, to give Cu. Remember that at the end of every electrolytic process, the substance is trying to become a neutral substance, right? So copper would become neutral, and the neutral form of copper is solid. Neutral meaning like its elemental state, right? It has no charge, it's in its elemental natural state, so it's going to be a solid. Copper is a metal, it's a solid at room temperature. It's going to be a solid. Now we need to figure out where we're going to put our electrons. In this case, right, we need to figure out where we're going to put the electrons and also the amount of electrons. Now, since we're going from 2 plus to 0, right, we're decreasing in oxidation number. Oxidation number is decreasing, and if the oxidation number is decreasing, we know that that is reduction, right? And for reduction, we're going to put our electrons on our left because that's the gain of electrons. Right, I have a YouTube video that talks about reduction redox reaction, so you can watch that video. Now, since it goes from 2 plus to 0, we're going down the number line 2 times. We're jumping 2 times, right? 2 minus 0 equal 2. So, therefore, we have 2 electrons for our cathode, right? Let me just, this was reduction here. Reduction is the gain of electrons, and that's why I have it on my left. Now for the anode, we have to consider 3 factors that affect preferential discharge at the anode. So for our anode, and we have to follow these in order. The first factor that we look at is the type of electrode. If the electrode is active, then this is the one that we just stick to. That's the half equation that we're going to write. That is what is getting discharged, right? If the electrode is inert, so let me just put a little thing right here. Active. If it is inert, then we consider the second factor, which is the concentration of the electrolyte. Right, so we have to consider the concentration of the electrolyte. If the electrolyte is concentrated, so for example, they say concentrated sodium chloride, concentrated copper sulfate. If the electrolyte is concentrated, then it will get preferentially discharged, right? And this factor does not go, it's not the same factor that speaks for the cathode, right? It's just for the anode, right? Yes, so if it is concentrated, it gets preferentially discharged. If it is dilute, so they say dilute copper sulfate, then we consider the second factor. So if dilute, we consider the third factor, sorry, which is position in the electrochemical series. And once again, the lower you are, the more likely you are to be discharged. And the lowest ion in the electrochemical series for our anions is hydroxide. So that is something that I remember. So these are the ones I try to remember. Right, so let us look for the anode. For the anode, of course, we need to consider the type of electrode and see if it's active. In the question, it did say that we're using aqueous copper sulfate solution using a copper electrode, right? And we said that the copper electrode is active, so therefore that copper electrode is what is going to be preferentially discharged. Now note, the electrode will get ionized, so it's going to go from copper. The electrode is something that we're looking at, something that we can touch. It's a solid, right? It's neutral, and then it becomes ionized. So that's what happens to all electrodes. They become ionized, right? And now we need to fill in our electrons. Yes, since here we have, it goes from 0, a charge of 0 to 2 plus. That's 2 electrons involved, right? And since at the anode we have oxidation occurring at the anode, oxidation is a loss of electrons. It would have been a minus 2e here, but we cannot have a negative symbol in any chemical equation, so it's going to be plus 2e, right? We cancel that, and whatever we do to one side, we do to the next side. So if we add 2 electrons to the left, we have to add 2 electrons to the right, right? But note that on the left side, those electrons are cancelled. So I can just simply erase here, right? And that is my half equation at my anode. Next question. Using your answer in part B, I explain why a redox reaction took place during the electrolysis of copper sulfate. And this one is very simple. Redox reactions involve electrons. Redox reactions involve electron. So all we're going to do, and it's 2 marks, all we're going to do is that we're going to write that this is because electrons were being lost and gained during the electrolytic process. Cu2 plus gained 2 electrons, while Cu neutral solid lost 2 electrons. Alright, now we're almost finished. So just one change that is likely to be observed at our cathode. Now notice that at our cathode it gained electrons, right? So right here our cathode gained electrons and it became neutral, which means that, for example, here, this is our cathode, the copper is gonna be, we're gonna form some solid copper on the cathode, right? That's what we're forming, which means that we're developing some mass around the cathode. And of course, for the observation, the copper, the color of our copper is, the color of copper, it is a red brown. Color of copper is red brown. So all I'm gonna put here is the cathode will gain excess red brown copper which is deposited around it, and it will look bulky. Right, the cathode, let me just insert there. Nice. And now I believe we're at the last question. So it says, explain how the electrolytic cell can be modified to plate copper onto a small piece of steel. Now notice how for the cathode, right, although yes, we're using copper, for the cathode we're getting something deposited onto the cathode, right? The question is asking us, how can we deposit copper onto steel instead of this copper electrode right here? And all we can do is that we can replace this copper electrode with a piece of steel. That's all we can do. And what's going to happen is that the copper is going to get coated around that steel. Note, and you can use this as a little remembrance, right? For your anode loses electrons and your anode also loses mass. Let me say it again. Your anode loses electrons and your anode also loses mass. But your cathode gains electrons, and it also, and it's not exactly the cathode that gains electrons, it would be the cations that gain electrons, right? I'm just trying to put it into perspective for you. So your cations would of course gain electrons there, right? And the cathode gains mass. So let me actually rephrase. The anode would, right, so your anions lose electrons, the anode loses mass, so the anode gets smaller, the cathode gains mass, but the cation gains electrons. Nice. Now let me go back to our question here to see if we can put it in a sentence. It's 2 marks. Explain how the electrolytic cell can be modified to plate copper onto a small piece of steel. Since we said that the cathode will gain mass and we need to put some mass onto the steel, therefore, and I'm going to write, the copper cathode can be replaced by placing a piece of steel, using it, using this steel as the cathode. That's the only thing that we can do, and once this happens, the copper ions from this solution will get deposited onto the steel, and that's our 2 marks. And note that for this one we're keeping the copper sulfate solution, the aqueous copper sulfate solution, that remains unchanged, and the anode is still copper because we do need to get some copper going off into the solution. Right, I hope we learned something. I hope you learned a bit. Right, thanks for watching, and I will see you in our next video.